So computing expectations by conditioning, and in particular this expression formula here, is very important. So as you can see, this is helping you to find the expectation of the marginal, okay, from the expectation of the conditional. Okay, so the margin of x is still being considered as random. X here is the random thing, y is being conditioned. So a way to think about what this whole thing is about is to think of the expectation inside this thing. This expectation itself is a random variable. Okay, so it is a random variable, it's expectation. So we know that you can take this as a function in terms of x if you think in that way. But then in particular, in order to find the expectation of x marginally, we are looking at the random variable of x given y, and then multiply with the probability of y equals to y, and note that you're summing over all possible y's. Okay, so if you look at, there are two expectations here, 1 and 2. Okay, so the inner one, which is number 2 here, is about expectation of x. Okay, and the second, or the first one outside, the outer one over here, as you can see by definition, is actually looking at expectation of y. Okay, so what you can think of is what's on the right hand side. It is a weighted average of the random variable ex given y. The weights themselves are actually the condition itself, which is about y. Okay, so we saw this law of total probability in the past. If you're looking at the event, probability of event E, you can look at the partition of fi, and then you look at the conditional probability multiplies with marginal of fi, and then you sum over all of them to get the marginal of E itself. So this in some way works in a similar format. These are the weights and being conditioned, and this is the new random variable. So you can sum over average, in sense weighted average, that you consider all of the values of y equals to y, and then average that out in terms of y in order to get the expectation of x. Lastly, for the continuous case, you have something very similar. The integral works with respect to y, okay, and you still have this random variable, the expectation of x given y, and you have this marginal PDF in this case when you're doing continuous case, and it's going to be your integral here.